Let's look at what happens when a chemical reaction occurs. Well, first we need to remember that if we put two solids together, the solid particles have very little motion to them. So any reaction that occurs with two solids is going to be extremely slow. We can speed up that reaction by taking our solute and dissolving it in water to make an aqueous solution. So when we talk about our reactions, we will assume that they are in water, occurring in water, unless stated otherwise. Let's look at two examples of what happens when a reaction occurs in water. Let's take the first reaction, where we have some sodium chloride. And we're going to take the sodium chloride. We'll also take some glucose. This is a simple sugar. We're going to dissolve each of these in water. We know that both of these are white crystalline solids, and they are both soluble. You know that. Salt and sugar dissolve in water. Let's look at the sugar first, the glucose molecule. Now, glucose has a formula of C6H12O6. It is a nonmetal bonded to a nonmetal. These form neutral molecules. When we look at a crystal of sugar, it's big enough for us to see. So there's not one molecule there. There are many molecules of glucose present. When the glucose is placed in water, it dissolves. But what does it look like? If you could see it with your eyes, what would it look like? Well, it would look like C6H12O6 units. They're small enough so that they can't be seen, but they still stay together as units. In contrast, what happens if we dissolve NaCl, salt? Well, when table salt goes into water, the NaCl also dissolves. But what it dissolves into are ions of sodium and ions of chlorine. Chloride and sodium ions. Now, here we have a metal to a nonmetal. And these formula units that we start off with split up to form these charged particles in water. Sometimes we say that polyatomic ions do not exist stably and independently. But here, they can exist with the support of the water around them. How does this occur? Well, this is a diagram that will help us explain what happens in water. If we have our sodium cations, they're going to be surrounded by water molecules. And these water molecules line up so that the more negative oxygens are closer to the positives, and the hydrogens are farther away. The water molecules encapsulate the sodium ions and prevent the sodium ions from coming near and associating closely with the chloride ions. In a similar fashion, those chloride ions, they too have the water molecules surrounding them, but the way the water molecules line up around the chloride ions is different. What's going to be near the chloride anion is going to be the hydrogens with their positive charges, and the oxygens are going to be farther to the outside. So we'll have the same sort of encapsulation occurring here with water molecules, and that's what prevents the sodium cations and the negative chloride ions from getting close enough to one another that we have sodium chloride forming. Let's look again, this time at a chemical reaction And the chemical reaction we're going to look at is sodium chloride plus potassium nitrate being dissolved in water. This is a double displacement or a double replacement reaction. Again, sodium chloride is going to dissolve. There is a rule for this. All members of the first family form soluble salts. So when we have NaCl, it will dissolve in water and break up to form Na pluses and Cl minuses. Again, the water is going to encapsulate them to keep them separate in the solution. What about potassium nitrate? Here there are two solubility rules that we could refer to. Potassium is a member of the first family, and so this would be a soluble salt. We could also use the nitrate rule. All nitrates are soluble. So when this goes into water, it will dissolve. Will it split up to form ions? It will. It will form potassium ions, and it will form nitrate ions. Polyatomic ions do not split up when they are in water. So, how does this affect the products of our reaction? Well, let's take a look and consider what would happen. These are going to remain separated from one another as long as they're in water. But what happens if you take, let's just say, salt water, and you remove the water by evaporation? Well, as the water evaporates off, you see salt crystals forming. What would happen if we start to remove the water here? Well, ions with opposite charges would be attracted to another. So, what compounds could possibly form? Well, Na pluses. The Na pluses might come together with Cl minuses to form sodium chloride again. Or the Na pluses might come together with NO3, nitrate ions, to form a compound. Then you would have K pluses. The K pluses might come together with the chloride ions, or the K pluses, the potassium ions, might come together with the nitrate ions. It looks like we have 4 possible products that could form. How can we show this in our equation? Well, what happens is that this reaction is said to be reversible. This is going to be shown by arrows going in both the forward and the reverse direction. We have a reversible reaction. Now, this means that the sodium chloride and the potassium nitrate move in the forward to form potassium chloride and sodium nitrate. These are soluble first family salts. And so they remain dissolved as ions in solution, and they can move in the reverse direction and back and forth and back and forth and back and forth and back and forth forever, as long as the water is there. But when the water evaporates off, 4 products could be found. Now, let's compare this reaction to a reaction between NaCl and AgNO3. When we have this reaction occurring, lots of similar things are going to happen. We would have the NaCls going into solution, and the NaCls would form Na plus ions and Cl minus ions. What about the solubility of silver nitrate? All nitrates are soluble. So when silver nitrate goes into solution, it too is going to break up to form ions. The ions it forms would be the silver, positively charged cation, and the nitrate anion. How is this different? Well, in this case, the silver and the chloride ions come together. When these 2 ions come together, they are going to form a precipitate. on the bottom of our sample. These are going to no longer be found in the solution. Instead, what we will have is a silver chloride precipitate on the bottom of the beaker. Sometimes we would indicate this with an S for the solid phase. In my class, I use a down arrow indicating a precipitate. So how many products are going to be formed here? Well, this is very different because the silver chloride precipitates out. That means that when the water is evaporated off of this reaction, we would then form sodium nitrate. What's the difference then in this reaction? Well, the reaction here is going to be, let's go back up, that if we have NaCl and AgNO3, the products of this reaction will only be two products. The NaNO3, sodium nitrate, and silver chloride, which precipitates out. How do we know this? Well, we need to know our solubility rules. And so this becomes very important. We know our first family salts, nitrates, and ammonium compounds are going to be soluble. Let's make a list over here. What do we know is going to be soluble? The solubility is going to be first family salts, acids. Those could be included under first family salts, but they're special, so we like to name them separately. How about ammonium compounds and all nitrates? What will not be soluble? Well, the things that will not be soluble might include sulfides, phosphates, carbonates, and chromates. We don't deal a lot with chromates for health reasons. So what does not mean? Well, it means these are not going to be soluble unless they're with a member of the soluble group. So sodium sulfide would be soluble, but something like an iron sulfide would not. The soluble rule always takes precedence over other rules. And the rule for silver chloride, well, that could be a slightly strange one. There are two of these rules that students need to be familiar with. And here's the first one, that if you have chloride, bromide, and iodide, just those three halogens, they are not soluble, or we could say they are soluble, except with silver, mercury, and lead ions. This helps us to explain a lot of the things that we see in chemical reactions when we're doing a lab. And I hope you understand solubility and the thought that there are really two questions here. Number one, does it dissolve? Number two, if it dissolves, does it split up to form ions?